So we were at uh, arithmetic operations on matrices. So if you want to add two matrices, right? So you use np dot add and you give the two matrices names here. So we used ARRN and ARRM. If you remember, we created these arrays. We created these arrays for an array of ones and zeros. Okay, so if you add them, you will get an array of ones, right? So 0 plus 1 will remain 1. So in the multiply part, you can either add a single digit. So I'm trying to add 10 to this array of ones using np dot multiply. Okay, or else you can also multiply a RRM to this. So if you multiply ARRN and ARMS, you get 0 multiplied by 1, all zeros. Okay. One thing we have to remember while we multiply is that these two matrices should be of the same shape. Okay. So what I might mean by this is by so ARRN, if you remember, was a 3 by 3 matrix, and ARRM is also a 3 by 3 matrix. Okay, so or an array. Okay, so these are arrays of similar dimensions, and that's why we could multiply them. Okay, so uh, uh, otherwise, what should happen is this should be something like 3 by 1, or then one by 3. Okay, so even this combination is multiplicable. Okay, so uh, you can try this combination of multiplications. You either they should be of the same shape, or it should be kind of opposite shapes. So number of rows should be equal to number of columns, and vice versa. Okay, then only multiplication is possible. Okay, you can also similarly use the divide function. And again, you can give an array here also, but if I give array n and array m, this will not work because uh, sorry, m by n will not work because 1 divided by 0 will should not be acceptable, right? Wait. So seems it is working. Right. So you get this warning, right? Divide by 0 encountered in to divide. So you get this kind of a warning. You get INF, which can be infinity. So one divided by 0 is infinity, right? So this is what you get when you try different combinations. So the rules of multiply are same as I mentioned. The matrices or the arrays which you are multiplying should be of the same shape, or should be in the shape of the rows equal to columns and columns equal to rows. So if you just try and create something like this and see if it is working, right? So np dot ones is now having 3 rows and only 1 column. Okay, and p dot zeros, try to create 1 row and 3 columns. So if you even this multiplication now uh, should work. Okay, so multiplication is working still. So again, if you multiply mathematically, if you multiply a 3 by 1 array with a 1 by 3 array, so 1 and 1 gets cancelled, and you should get a 3 by 3 array as a result. Okay, so this is what is happening here. You're getting a 3 by 3 array as a result. Okay, So these are the combinations of multiplications which are acceptable. So is this one kind of clear, or are any doubts here? Are there any doubts? Can you confirm, please? We can move to sorting then, if there are no doubts. Concatenate is different from add, right, Rajesh? Because concatenate, what it simply does is it will basically it is adding these two arrays, like you get 1 2 5 all the elements, right? 1 2 5 6 3 4 7 8. What will add do? Add will add these elements, so you get 5 plus 1, 6 plus 2, 3 3 7 4 8, right? So you get 12 10 8 6. So these are two different operations, right? So don't confuse between concatenate and add. So does that clear it out? Okay. Fine. We will move on to array sorting. Okay. Uh, remember, adding is for adding the elements of the array. Concatenating is just combining all the elements together. Okay. So yeah, that's the basic difference there. So we move on to array sorting. Okay. So array sorting here, what we are doing is we are creating this two-dimensional array, which is 2 by 2. Okay, 2 rows, 2 columns. So we are uh, we are trying to sort it by using this np.sort function. We are giving this array as the input a8, which we just created, and we say axis is equal to 1. So axis is equal to 1 basically sorts horizontally, and if you give the axis value as 0, it will sort vertically. So we'll see how does that go. Okay, so you can also give none, which will create basically a one-dimensional array. Okay, so you see, if axis is equal to 1, it is sorting horizontally. So what do I mean by that? Let me just try to, sorry, put visually. Okay. So sorting horizontally means sorting like this. Okay, so if this is the array right now, right, this is the array, because this is the first row and this is the second row. Okay, so something like this. So if you try to sort horizontally, you should get 5 this side and 10 this side, increasing order, right? So 5 will move this side, 4 will move to the left as well, 8 will move to the right in the increasing order. So that is the first print statement. That is the first result, right? A9, if you see, uh, 5 and 10 are sorted in increasing, 4 and 8 are sorted in increasing order. Okay, so this is how we sort horizontally. Okay, if you want to sort vertically, what will happen? Again, you can visualize. Vertically means 8 should move up because it is smaller, and 4 should move up here. Okay, 5 will come down. So if I print this after vertical sorting, the result is something like this. Okay, so 8 will move to the upwards because it is smaller, 4 will move upwards, and 5 will move downwards, again in the increasing order, up to down increasing order. Okay, so if I give access as none, what is happening here? It is giving me a linear uh, output. Okay, one dimensional output. Now by arranging in increasing order left to right, 4 5 8 10. Okay, if I give access as none, this is how I get the result as. So this block is clear. You can ask if any questions are there. Okay, thank you. Anybody else? Any doubts? Please confirm on the chat. Okay, fine. We will move on to array searching. So you can search for minimum and maximum values in your array by using again by using some built-in functions. Okay, so how we do it, we'll see now. So we create this again a 3 by 3 matrix, right? And we are trying to print it, and then we are saying arg max. This is the function which gives you the index of the maximum element, the max, the largest element in the array. Okay, so uh, by the indexing, what I mean, we'll see now. Uh, then this index, whatever is the result, we are storing it in this variable m. Okay, then we are trying to print that index number. Okay, so uh, you you will see how the lateral indexing works. So first of all, again the axis rules are same. Um, if axis is 0, it is vertical, and if it is 1, it is searching maximum values horizontally. Okay, so if we try to print this block, you say we'll just first trying to print the array itself, and then we are searching the maximum, the the index of the value which is the largest. Okay, so how this works is basically this value is coming from indexing like something like this, because you are searching the index for one individual element, so it's not any coordinates. So how this is working is it starts from left to right. So you see this is the 0th element, and this is the first element, and the second, third, fourth, and fifth. Okay, so this is the fifth element, which is the largest element. Okay, so if you go from left to right and top to bottom, you get the fifth as the fifth element as the fifth index value as the largest index value. So that's so then we are printing that index value, which is 5. Starting from 0, we get till 5 here. Okay, 8 is the maximum value, right? So this is how we get this 5. Okay, and then talking about vertical searching for maximum value, you search uh, top to bottom again, and you see for each column which index has the highest value. It's all about indexes here. Okay, so if you see this column 362, this column, this is the first element 0. This is the first index 0. This is the second index 1, and then the third index 2. Okay, so here you can see the middle index 1 is the highest. Okay, so you get this 1. That's how you get this 1. Okay, and then the second column, you again see it first there are two max values, 7 and 7. Okay, so you get, so what the largest value it encounters first, it just prints out that index. Okay, so when it is traversing from top to bottom, it gets the first maximum value 7, compares it with this. So this is the largest. The first value it encounters was this 7. Okay, so again we get the 1 because it is the middle index 1. Okay, then the largest the last column 586, you see again the middle element is the largest element. So you can try this. We can make this element as the largest. So you will see in this particular output, you will get last element is 2 now. Okay, 112 should be the output here. Okay, because in the last column, the last second element 0 1 2 is the largest element, so we get 112. uh, and horizontally, when we say axis is equal to 1, similar thing happens from left to right. So indexes are assigned from 0 to 2 again. So here, as you can see in the first row, uh, 0 1 2 2 is the highest, right, out of these three. So we get 2 here again. Here 2, second element, 0 1 2 is the highest, so we get 2 again. And for the last one as well, we get 2 because 9 is the highest. So you can try to change this. So we'll make this middle element the highest one. So my output should be for argmass axis equal to 1. My output should be 212. Okay. So now it is changed to 212. So this is how you find uh, vertically and horizontally maximum values in your arrays. Okay. So any questions here? Um, you can, if you want to understand, you can just try to simply play around with these values. You will get a, keep printing for different set of values. You will get the picture. Okay. So are there doubts here? Can we move to the last two sections?
Kaushal, should we take a break, come back and do this, or can we complete in the next 5 minutes?
We'll complete in next 5 minutes, sir. We'll go for the break.
Sure, Kaushal. Okay.
I'm
No,
go to the.
yeah.
So if there are no questions, we will move forward. Mm, uh, last two functions here, and that after that we'll go for the break. So we this function again, one of the inbuilt functions, count underscore non-zero. So for this linear one-dimensional array, we are trying to count all the non-zero values. Okay, so we give the array as the function parameter a130 a13, and then this function basically should print me how many values. Can somebody quickly tell the answer in the chat? How many values should this print? Non-zero. What will be the answer for this if I try to run this? Right. And there are four non-zero values. So my output will be 4. Okay. And lastly, we have this function np.where. Okay. So we use the same array here. So this again, as it is aware, we will get all the indexes where this array element value is 10. Okay, so we should get ideally only the index number first, the first one. Okay, that is we should get 0 as the answer. Wait,
अरे आप कहाँ हो? अरे मैं फूल ले रही दुकान में नहीं, इधर ये फूल वाली दुकान में. अरे उस दिन नहीं लिया था जो हमने फूल दोनों ने. अरे अरे सुनिए ना, सुनिए तो.
So I think we need a print here. Fine. We will. I'll try to see what's the issue here. You can also try why it is not giving me the value, or maybe we should try to experiment with this. If I give 0, right, it's giving me the same thing. You can try the syntax here. Okay, let me just. So I'll leave this up to you. You can try for this. there is some issue here where I'm not able to get the index value. So ideally, it should give me the index for wherever my array value is equal to 10. Okay, so you can try this, and also you can try this assignment. Uh, as I said, 3D arrays and accessing its elements is uh, is one of those assignments. You can try this and you can let us know. Did anybody get this? np.where you can try your resources. I think there is an issue. There is an issue here.
अरे तो मैं शुभम को भेज रही हूँ ना, शुभम को भेजो। अरे शुभम को भेज रही हूँ मैं, कहाँ पे हो आप बताओ सही।
We can. So Nandu is asking how can we print the highest value inside the array instead of printing the index. You can use the argmax function, Nandu, same as we use. So you can, so for all the elements, all the values, you can simply use this. You will get the index. Is that your question?
उसको बोली वो बोली आंटी को
For
वो गया ही नहीं।
or okay, if you are asking if how can you print the index of the number, you can simply say
मैंने वहीं से बोला नीचे से, मैं आंटी को ध्यान
बोला तो नियम है अकेले
चले जा रास्ते से गया ना। चले जा कुछ नहीं होता।
so did I get your question right, Nandu? Independent highest value inside the array. Still printing this. Okay.
बोला आंटी बैठ जा।
Inside the array, if you want to see the value, you can see the index, or you can use the you can simply use the argmax function. You will get the index of it. Okay, and if you have the index, then you can locate the array, right? Sorry, the array element, right? There is a different function for that. You so you can try to explore on that, because yeah, argmax is printing the index, but with the index, if you like try to print the array with the index, like something we did before, right? So you will get the array value as well, which is the highest. Or you can use some other indefined inbuilt function as well. I'll leave that up to you, because try to search for other inbuilt functions which are there in the NumPy library. Okay. So if you get that function, you can also tell me. Okay. Yeah. And try to find that function where you can print the value instead of the index, right? Maybe there can be something like max or maximum value. You try to search in the NumPy resources.